Well, welcome everyone. Thank you again for joining us on our electrification series. My name is Larry Waters. I'm the owner of Electrify My Home. Also in the background is the brains of the outfit. Alex Sloan is in the background today too. We really appreciate you coming to spend a little time with us today. Hopefully we'll give you some content that you're going to be able to use. We always start every conversation with every customer and every one of these webinars by talking about our own company's mission statement. Our excuse me, our mission is to provide the most most efficient, cost-effective electrification solutions, being a good steward of the electrical panel, and that's what a lot of this is about today. And of course, one of our main functions of our company is to train and influence other contractors to better understand home electrification and the intricacies that go behind this. It's not just putting in a heat pump. That's a pretty important part of it. So we got the safety message and the welcome view. Hey, I added one last time too. Hey, it's going to be raining soon. Wiper blades are on sale at Costco. Just thought I'd let you know on that. We'll go over the Electrify Efficiently webinar series, what's left in there. Today, we're really going to talk about what's important about the electrical panel and understanding that whole side of this, what's wrong and right with panel upgrades, some solutions that we use for capacity challenges, and then we're going to share a couple real world examples. Really stay on till the end of this because it'll all it's got like the plot twist all comes to an end at the end, and all your questions will be answered with real live situations that we've dealt with. So this is the third in our series in this grouping, electrical panel assessments, examples for heat pump installers. Next time is going to be operating a heat pump, best practices to minimize callbacks. That's a really good one because it's really about setting expectations with your customers. This is a great one for HVAC contractors and just being able to explain heat pumps. And then we got the big one on 1215. That's the way we zone heat pump systems, and we're going to look at a couple of different options there too. So some good ones coming up as well as today. So hashtag electrify efficiently. A lot of you might see the electrify everything hashtag out there, and I think I'm a little bit more of a realist when it comes to that. Every building I look in or every time I look at anything, I'm like, how do I electrify that? So, and the way that we electrify everything is with this backdrop of efficient electrification, using the proper appliances and methodologies so that we can do it as efficiently as possible. So we're really into building electrification. Single family residential is what we're into. We do lots of heat pumps and heat pump water heaters. We like to train on overcoming heat pump electrification barriers. We share approaches that will optimize comfort, efficiency, resilience, and lower operational cost. And all the audiences will benefit from this. This is good stuff for everybody that's in the industry, whether you're a builder, you're an HVAC technician, HVAC company, whatever. You're going to get some benefit out of this if you're looking at home electrification. So without further ado, let's talk about the importance of the electrical panel. So realistically, the electrical panel is pretty darn important when we're electrifying things. I think we could all agree on that. There's different ways to do it in different homes. There's different loads that we're not going to share in here necessarily, but what we're coming with you or at you today with is what we see most of the time and some of the solutions that we've done on projects that we're, needing of a little bit more finesse. So let's think about things for a second. So the electrical infrastructure in your house is really the brain of electrification. Our brains are what drives our bodies, but there's other organs in our bodies that kind of keep us going and move everything. But the brain is where everything is really starting from. And just like your home's electrical system is being, the electrical loads inside the house are being driven by this electrical panel, we look at the electrical infrastructure of the house as the brain of the system. And if the brain isn't powerful enough to drive everything, then we have problems. So we also need to understand that heat pumps are the heart of electrification. So heat pumps are going to be, most of the time, they're going to be our most important load that we need to manage and we need to design around. There's a lot of other things when we look at all of the things customers are going to be electrifying in their house over time. And most homes in California will be completely electrified at some point. We need to make sure that we're paying attention to our hearts. And our hearts when we're exercising, like when I'm on the treadmill and I'm getting my cardio going, and my heart is moving a little faster because it's keeping up with demand. And then when I'm at rest, like doing these things, like this is relaxing for me, so my heart rate's probably pretty low. And you know, my blood pressure is real low right now. I'm kind of lucky to have low blood pressure in my life, but the heart is a variable speed heat pump. Your heat pump is going to move heat throughout your home. The heart is moving blood throughout your body. It has the ability to speed up and slow down. We want to look at heat pumps that are going to speed up and slow down as well. So here, tying the analogy together, we need to make sure we use the right heat pump for the right application. One, hopefully that will, like our heart does, speed up, give us what we need when we need it, when we're really exercising or when it's cold outside or really warm outside. We need enough capacity in our heat pump to keep up with that demand. And then we also need it to be the right size for when the demand isn't quite as much. So basically when we're sitting down and relaxing in our chair, is basically like what your house is when it's at thermal equilibrium and it's a reasonable temperature outside. Your heat pump should be able to slow down just like your heart. So the other part of this analogy is don't fill your brain or your electrical panel with a bunch of garbage you don't need, which in our opinion is like electrical strip heaters, 220-volt air handlers that are secondary to the internal or to the external unit. We want to keep our mind sharp. We want to put systems in our houses that are keeping our electrical system sharp. So what is this? So we have a couple of electrical panels here, and at first glance, and there's a lot of people don't necessarily understand electrical panels. At first glance, they're going to open this thing up and they go, "My God, this thing is full. What am I going to do?" There's often options when we get to this point and we say, you know, all our spaces are taken. I need to add 5 loads to this house. What am I going to do? How am I going to do it? And can I do it on this existing panel? So the question is, are these panels full? Well, the answer is maybe. But before we get to that, we need to know a little bit about the power law. And I'm sure some of you guys out there know this and others maybe not. But the important concept here is the power law basically means my wattage, depending on my voltage, my wattage is going to dictate my amperage. In other words, if I have a 120 volt load at 1200 watts, what is that going to be? Is that going to be 10 amps? Because it's a nice, easy math transition there. But these things all kind of work together. We need to understand this and how all these things work so that we can understand how panels size out. So power is your watts. This is how much your appliance needs, how much energy your appliance needs to run. That's going to be based on the voltage. So if you have a 120 volt unit or a 220 volt unit, whatever that thing is, whether it's a toaster oven or a heat pump, it's going to have a specific amount of watts it uses in certain modes in that operation. And then that's going to dictate how many amps this thing pulls. So these are very important to know. There's a couple of other points in this that are important to know too, is electricity can kill you, but don't fear the electrical panel. So many people like, it's like mind-boggling and like it's electricity, it's really dangerous. People think the same thing about gas, but when you're trained to do it and you understand how it works, the electrical panels, if you take the proper precautions and you do things carefully, are not quote unquote unsafe if you're dealing with them safely. So how much power do we have in an electrical panel? And this sometimes trips people out. So a 100 amp panel, so that's 100 amps. This unit is capable of delivering 100 amps at 240 volts. That means you can have a maximum carrying capacity of this thing, which would usually be peak in most cases, of 24,000 watts. 24,000 watts is a lot. Is a really lot. So we look at 100 amp panels as an opportunity to electrify most homes on 100 amps. But when we get into the outlying things like solar and batteries and car chargers and things like that, which are usually like secondary goals for customers, most of our customers either already have solar or we're getting the initial stuff put in before they get the solar. I would say only a small percentage of the houses when we come in them have car chargers, but all this stuff needs to be taken into consideration. And then when we have a 200 amp panel on a house, man, we feel like that's like riding in a limousine, man. There's just a lot of room in there. It's really comfortable. We don't have to worry as much. But if we always keep our eye on the prize with 100 amps, we're always going to make better decisions for the customer for energy usage later. So even if I have a 200 amp panel, I am still going to design a low energy heat pump system, and I'm going to make decisions based on what type of heat pump water heating system they have, or maybe the stove conductor or the dryer conductor, or maybe they have 200 amp panel, they have a pool or a spa. But we need to make sure that just because we have a larger panel, we don't really want to rest on our laurels and go, I have a lot of room in here, I'm just going to stick a 70 amps worth of heat pump in this thing. So a lot of power here, kind of the takeaway on that. It's a lot of capacity. So this is this was a study that was done from Home Energy Analytics, HEA, on PG&E houses. They looked at 22,442 of them. We were looking at maximum amps over a 12-month at 240 volts using smart meter data. So this was the peak of these homes, looking at them for a whole year, wherever that peak event was in that whole year. And if you're electrifying your house, that peak event might be on Thanksgiving Day when you've got your electric range cranked up and you might be running a little heat in the house, or whatever times you're going to be using a lot of your loads, and probably using a pretty heat pump water heater, etc. Probably have guests in from out of town, so they're doing laundry, and you're going to use a lot of power. But what they found is, if we look over here at the homes that have maximum power level and then maximum amperage over 12 months, this is really how high the amperage went in all these number of homes over a long period of time. What they found out was 98% of the houses out there never went over 88 amps in a year, in a whole year. And now we don't know, there's probably a lot of mixed fuel gas customers here, and we don't know what the panel sizes were on these. That wasn't part of the research, but we do know that 98% of those houses never went over 88 amps. We would hope that houses that are going over 88 amps that might peak over that might have a bigger panel, but it doesn't need to be that way. 86% of those houses never went over 50 amps, and 48% of those houses never went over 30 amps. So what does this mean for us as electrification people is that there's lots of unused capacity for electrification without a panel upgrade. And if we size this stuff out and we pay attention to the details and we look at low energy applications, we can optimize this pretty well. Not a big deal. So this is a little bit of a different study that they were looking at. This is a SMUD study, and the SMUD study was looking at mixed fuel customers and electric homes only. And this again from Home Energy Analytics, and it's about peak kilowatt distribution. What we find is the demand curve changes with electrical. In other words, we're using more electrical over time than we are with a mixed fuel home, which is obvious, right? But what we find is down here at the end, most of the houses end up not peaking out at a higher level than, I can get this thing working here. Okay, never mind. Most of these houses, whether they were partial fuel or what they call mixed fuel homes and electric homes, never really used more energy when it came right down to it at peak rate. We got our different way of using electricity and kind of our different load profile. But when it comes right down to it, it's pretty close at the other end, like 20,000 watts. And we're looking at 24,000 watts in a 100 amp panel. So we have capacity in a lot of these houses. There's a lot of houses that they looked at here. So we know that even when we're adding electrical loads, we're really not peaking out more than gas electric houses. Okay, I touched something on my screen. Okay, here we go. All right. So this is a fully electrified house example. And this house is built in '59. This is a tight house. We did a nice insulation job on it. Actually, the customer in this house did a fantastic insulation project, even after we kind of came and did ours. This was a flat roof house at one time. They had a roof built onto it, so they had insulation between the old ceiling and the flat roof, but it wasn't consistent. And then they had a weird eave structure that was built around this new roof. So the customer actually took it upon himself, read a couple books, and went and tightened the house up pretty good. But not much more than we could do in an average house with a standard roof and a crawl space. We get houses that tight all the time. But this house was built in ~59. It's just under 500 square feet. We installed a 2-ton Mitsubishi inverter. By the way, they had a bid for a much larger, well, not much larger, but 50% larger system, just based on rule of thumb and 1420 square feet. We happen to be the only ones that came in with the inverter plan. With the inverter, this 2-ton Mitsubishi inverter is a 20 amp breaker. This customer, we also installed a 50-gallon heat pump water heater, a 30 amp model. They have subsequently gotten an electric range and electric resistance dryer. And I think he's planning on going with a heat pump dryer, just because the guy that's doing this is savvy and wants to use as little energy as possible. But what we found, looking at a year's energy data from an energy monitor that we installed on this home when we did all this work, is that their peak time in the year, they were only using 3,200 watts at peak. And so 3,200 watts and 24,000 watts in a 100 amp panel, there's a lot of room to do other stuff in this house, strictly looking at the load. Although if we add up all the circuits and we look at the load and we do an actual load calculation, we may be closer to 100 amp on a load calculation, or right at 100 amps on a load calculation. But bearing it out with how people really live, this house never goes over 3,200. So a pretty good example of actual energy used and energy needed to kind of satisfy the utility. So now, learning that, now that we know that houses don't peak over, the 98% of houses don't peak over 88 amps, and most of them are way less than that. We know where our load profiles are, that our mixed fuel homes and our all electric homes are really peaking out at about the same point when they do. Are these panels still full? And so the question is still maybe, but I feel way more confident in these that there's plenty of power to carry what we need to do. So how do we do it? So what's wrong with panel upgrades that we see out there? One thing is they cost a lot. So if we can avoid this cost, and what our thing is we're being called in as kind of the first measure a lot of times. And we're being called in a lot of homes that have 100 amps in the house. They don't have any more than that. A lot of them have over wire feed or outside wire feeds. Really old housing stock, a lot of what we work in. But the panel upgrade costs, what we found is if I could put a new panel in the exact same spot where the old one was, and there was no jurisdictional issues or anything like that. And it was just a panel upgrade, like I'm replacing a bad panel with a new good panel, and maybe even keeping it at similar capacity. We're talking $3,000-ish for that minimum. If I'm moving it down the wall because of the gas meter, doing something like that, or I'm going up to a 200 amp panel and I need to put in a larger weatherhead, or there's other things that need to be done, that can get way more expensive than that at 8,500. And God forbid if we have wires coming in from the street and we need to increase the wires. We ran into this problem the other day. Certain neighborhood we're working in, the wires coming in through the street aren't actually in conduit. So the utility company wants conduit in there if we have to do it. So we use some different strategies with them because it just wasn't going to be financially feasible to do trenching and pull new wires and things in. So we'll go a little bit more into that house in a minute. So panels can also be super complicated if they're just not big enough, or if they're really old school. We got pictures from a customer the other day, and then she's sharing them, and we're looking through the 2 sub panels she has in her house, and she shows this picture of the main panel, and it's literally a 100 amp fuse pull out. It's feeding a small sub panel next to it, which has a breaker that feeds a panel, and it's a really old school sub panel, so there's no way to like break it up or do anything like that. And then and then the other sub panel is a Federal Pacific. If you all know what a Federal Pacific is, Federal Pacific is not something that we wouldn't hook up to anything other than very temporary. But or if it's over the gas meter. This is a big one right here, because you're not going to get approval from anybody to put a new panel in here that's over this gas meter. So what is the solution for that? What we do most of the time is we'll use temporary circuit splitting device. We'll talk a little bit more about that in a minute. We'll come up with a strategy to degasify everything and then get this meter removed, and then it gives us much more flexibility on what we can do here. And sometimes getting this meter removed, depending on where you're at, like at my house, when I had my meter removed, it meant that the stub coming out of the ground was now 3 feet away from my panel, so they didn't bother pinching the pipe off in the street. We have had some other customers where they wanted the new panel here and it was still going to be within 3 feet, so they actually dug up the street and pinched off the pipe out in the street. That's such a permanent thing to do. Or we think of it as permanent. When they bring out tractors and make things work, they make it look easy, but maybe because there's 14 people there. But just keep in mind, there's jurisdictional or utility restrictions on these different things. So windows, distance to the gas meter, where we're going to move the unit. Sometimes we'll have this where the gas meter's here, the electrical panel's here, and the front of the house would be here, and there's a fireplace here. So like we would have to take all this wiring and somehow move this panel on the other side of the fireplace, or move it. Just it sometimes ends up being differently than you think it's going to be too, because you have to get it approved through the utility company, and they might have a different idea of what's logical than we do, because we're looking at the house in real time and experience of doing all these. But they have the experience of knowing how that grid is, knowing how the electrical system works, what the rules of Green Book rules are, all that stuff we need to follow. So I had one where we were going to take this electrical panel and move it into the garage right behind the wall, which would theoretically put a wall between it and the gas meter, which to me, I mean, adds 3 feet of space. I haven't heard back from them on whether they're going to let that go or not. So I'm not sure. And that's a hard one to explain on a form. But these are some of the important things that come into play if the gas meter's in play. Now, we have a customer in Albany, and we did the application to get her a 200 amp panel upgrade. I thought it was going to be harder than it was. We put in the application, they did a drive-by out there, they took a picture, or they took a look at the wire, and apparently the wire coming down to the weatherhead is big enough for 200 amps capacity. Apparently the neighborhood will handle it, so they gave us approval to do it. However, it's in a closet like this, and the electrical panel is here, and the gas meter is right next to it. So what they gave us approval to do is put a new panel 6 feet down the wall, and it wouldn't have to be 6 feet, but they have a gate that opens, so that made things even worse. So they gave us approval to do that. We're putting the panel down the wall, and then we have 10 feet to bring the weatherhead over to where they can connect in the weatherhead. So which does give us the ability to go hang our panel, get all our secondary electrical circuits that aren't in place yet for this house, and then do the final connection into that. And then we'll move a few circuits from the existing panel into the new panel at that time. So I was surprised at their approach and how they wanted to do it, but as long as we take what they have into consideration and follow their instructions, it's all good. And once again, that was a panel that was not able to be added to. It was another fuse pull-out panel with screw-in fuses, so just wasn't able to do any kind of electrical upgrade on that. Now I have gone to houses like this where this is a 100 amp panel. It's all good. They have gas dryer, gas stove, gas water heater, and gas furnace, and we're electrifying almost everything in the house through this panel just by adding a sub panel to this and bringing some of our loads out of a sub panel, and then circuit splitting the water heater and the dryer. Okay. So utility infrastructure must support worst case scenarios, and they're looking at this from, sensibly, we know by this data and everything that we get and we look at all the time that houses are only going to use so much power, but they have to look at it like it's under the worst case scenario. And we have to understand that everything here in the red is what the customer owns. Everything beyond this is outside the customer's control. However, these people do have control over what's going on with the customer. They can say yay or nay on what's going on here, even though the customer owns it. But the customer can't say yay or nay on this part. So if they have a wire coming down that's only capable of handling 100 amps or 125 amps, and these people need a 200 amp panel upgrade, maybe they got a really old panel, they want to get a 200 amp upgrade because someday they're going to have a couple electric cars, they're going to put solar batteries, whatever the case may be. The utility is going to dictate how this can happen, even though the homeowner owns it. So, and then this wire might be the breaking point from being able to afford this project or not. If this wire isn't the right size, and say the transformer in the neighborhood doesn't have the carrying capacity of 200 amps, there's a lot of utility-owned infrastructure that needs to be modified in order to make that happen. So if they have to go into engineering phase, when you fill out these forms, you're automatically agreeing to go into engineering phase. And they'll let you know, like, it's going to cost $3,500 to look at this further. So owner's responsible for this stuff. Hopefully their electrician, and then utility over here. So the service steps for utility upgrades is pretty easy. It's easy to fill out the form. It was easier than we thought it would be. We've done a bunch of them now, but the planning phase, let the utility know, get in contact with them, get a dialogue opened up with them. Most of these guys will call you back in a day if you have questions. If you put in the application, they try to get back with you within 3 days to ask any follow-up questions or anything like that. Load assessment or service design, this is exactly what they told me on when I called in on yesterday, was that there are 30 days. It's a guaranteed at least 30 days to get this back. I haven't had to go through the contract and payment part, so I'm not sure how long this part takes, but the last one I did where we were upgrading that 200 amp panel was about 60 days total from them telling us from me requesting it, to them checking it, to them telling us what we could do and authorizing us to do it in that way. And then you have to, obviously, when you're going to do that final connection to PG&E stuff, because they're really those wires coming into the house, the owner owns here, the wires coming in here, the panels down here, that meter belongs to them. It's not supposed to be pulled out. You're not supposed to do things hot. So we don't want to do that unless we absolutely, we don't ever do that. I mean, I guess there's certain situations that the electrical panel is down on a Sunday and can't get anybody on the phone, but they'll even come out to do that for an emergency. So what are some of the solutions that we can use? When we're looking at electrifying the home, this is pretty much the choices that we have and kind of what we need to expect. So we need to make space in the panel for these different things. Now, the heat pump, this is the reason we call it the heart of the system. This is the brains, this is the heart. Excuse me, I don't have a cough button. The heat pump can take 2 spaces, or if it's not designed properly, it can take 6 spaces. And 6 spaces would be like a traditional unitary heat pump. Traditional unitary heat pumps tend to lose a lot of their heating capacity around 40 degrees. And so some contractors want to install a secondary heat strip that picks up when the heat pump starts losing and kind of sublets that. But if you have a heat pump that's over here running and it's using energy to heat the house and it gets to 29 degrees outside, which it does by us a lot, gets to 29 degrees outside, a traditional heat pump is going to lose a lot of traction there. So that would cause the indoor unit to, or the multi-stage thermostat to say, we're not keeping up, we need to bring this strip heater on. So now I have a heat pump outside that's not working well, that has a relatively good, what we call coefficient of performance when it's working really good, and still better than 1-to-1 when it's not working as good. But now I put on a strip heater, which is a giant toaster element. And sometimes these strip heaters are 5,000 watts, sometimes they're 10,000 watts, sometimes they're 15,000 watts. And those are a 1-to-1 load, right? You're using 15,000 watts of power, 1.5 kilowatts. Anyway, 15,000 watts of power to run that heater. I've still got my heat pump running on the outside. And so it completely shoots out hours and hours and hours of heat pump. Good efficiency is offset by a little bit of time when it's using a heater strip. So this is what we were talking about. Don't put the garbage in your brain. Don't put in circuits that you don't need. Don't use systems that require a lot of breaker space. We only use the type of inverter technology that's fully communicating. And for all of the systems we install, I don't want to say all, most of the systems we install, like in the high 90% range, is 2 breaker spaces, usually 20 amps, sometimes 25. And that 20 amp breaker feeds the outdoor unit, and the outdoor unit feeds the indoor unit air handler. So I really only have that 1 breaker associated with the heat pump. With a 6 breaker, you're going to have a 230 volt air handler, a 230 volt outdoor unit, and a 230 volt heater strip. So if you're a customer out there, somebody's coming to talk to you, then if somebody's coming to talk to you about a heat pump and they recommend that thing, like, call a couple more people. So dryers are going to take 2 spaces. If we have a gas dryer, we need a big fat breaker for 2 spaces. The water heater, in most cases of the 220 volt heat pump water heaters that we're really used to, the ones that we've got a lot of them out there, those are either going to be a 15 amp, which is we found as a special order, or a 30 amp unit. That's got the 2 secondary heating elements and the heat pump. But another solution that we've been using a lot of lately are the 110 volt plug-in water heaters. Those things work astonishingly well for what they are, but there's design around that. We'll have a design class for heat pump water heaters coming up as well. The range is always going to be 2 spaces. It's going to be 50 amps. But one of the things about the range is it doesn't run all the time. So it slides into the reduced coincident factor of the energy load. And then EV chargers, which do not. You cannot derate the energy charger or the EV charger because it runs for so long. The wires can really heat up. So they don't let you coincident that. Or coincident means when you figure out your panel load, there's a certain amount of that power that you can derate to 40% because it doesn't operate all the time, right? So it's incidental load, coincidental load. So all of these breaker spaces, we have a choice of 2, 4, 6, 8, 10, or 14 spaces. So how do we get this in a panel that's full? So this is this panel full? Pretty nice workmanship on this. This is obviously a picture of an industrial panel where they ran THH in line in, and the electrician obviously had a lot of time to do things very beautifully, which is nice. It's a beautiful panel. Not all residential panels look like this. Most don't. If there's Romex coming in here, it's never going to be this pretty. But what can be expanded on this by, we could replace the wide breakers here and quad out. We can quad out a couple of doubles. There's a lot of opportunity in this unit to add more capacity. And you can see up here, it's a 200 amp breaker. So this is an overfed, underutilized system. There's not near 200 amps of required load here, but there's 200 amps of service here, which is important because if we put in a 200 amp system, a 200 amp panel, and we don't utilize 200 amps, the utility company still has to recognize that there's a capability of that house using 200 amps of power. And so if they don't need to do that, if we can do it on 100 or a 125, and we can be really smart about the power sources, then that's going to allow more capacity in the neighborhood for the people that actually need it. So I was starting to talk about this customer a while back, and she got a hold of us. They were having a neighborhood meeting, and they were talking about electrification. We got a couple of calls out of that meeting because one of the guys that was in the meeting, we did a job for. And so this lady came on. She said that she was the one we're going to move the panel 8 feet down or 6 feet down the wall. She said, I really want somebody to come in and do this with a permit, because what we discovered on this call was the majority of people that got panel upgrades in her neighborhood did not get permits. So people came in and wired them hot, which means probably some people got 100 amp or 200 amp panels on 100 amp wires, or they've got 200 amp panels in there. They're adding more loads, and they might have had a 200 amp wire, but the utility company doesn't know about it. That causes huge problems. So don't get a electrical panel installed unless there's a permit. It's a pain, but you got to do it. So here's another way. Another one we use a lot is if we need more space, we just install a sub panel. When we do install a sub panel, we put a little thought into that. So we install a sub panel depending on what the load is for, and we'll only install a sub panel that has the capacity to carry the amount of power that we run on the main wires. So if I have a 100 amp panel here, a 100 amp capable panel, but I only have 4 breaker spaces here and I'm going to use them all and it's only 60 amps, I'm just going to run a number 8 wire to this thing. It's not going to be enough for that customer to come in and go, I have a 100 amp panel here, I'm going to fill it full of 100 amps of stuff. So you want to be cautious when you're designing these. Make sure your feed wires are the right size. Never feed a sub panel with less than a number 8 conductor, which is 50 amps. And always land the neutral in these. Don't do two conductor Romex with ground, because that can cause some shock issues down there, especially if you're going to use a 110 circuit out of this. If you're running this and it's going to be 220 volt circuits, so that's less of an issue, but you still want to get it right. So if you have a 60 amp breaker here and you're going to use 230 amp breakers here, and you're in a panel where there's no extra space, I wouldn't worry too much about it. But if you're going to put in, like in this diagram here, a couple of 30 amps and there's still bus bar ready for other circuits, I would probably run a larger wire to this, because chances are somebody might come in here and tap off some of this power and you don't know what they're going to do later, and they might not do a good calculation. So be careful with your sub panels, but these are a great strategy. So here's some solutions to full panels. This is one of the full panels we asked you earlier if it was actually full. And this panel, you know, it's got a lot of breakers in it, but it's got a lot of 110 volt loads in it. They're taking up a lot of space with these circuit interrupt breakers. Really the only thing in here was the air conditioner. They had a bedroom mini split. They had the solar and a dryer. So if they wanted to add a stove or something, or some other circuit, there's room in here to do that. We would quad it out. take the dryer outlet or the dryer breaker and quad it out and use that extra power for the heat pump water heater set, because it actually says heat pump water heater right here. I know this slide. Solution to fuel panels, add a heat pump water heater circuit. Again, another way of doing it is a circuit splitting device. Now, circuit splitting devices are something we use a lot in our strategies, and sometimes we use them as permanent solutions and sometimes as temporary solutions. So one of the things I mentioned earlier is if we can get rid of the gas meter out of the equation, it makes everything a little easier with PG&E or with any utility. I'm not singling out any particular utility, but when you call them and you're within the kind of the fire range of a gas meter, getting the gas meter out of there makes it easier to put a larger panel in later, because the gas meter is not part of the equation anymore. So we do have houses out there where we're using a circuit splitter as a temporary thing until they can get situated on their new panels. And that way we can get the gas meter out of there and get all that. These devices are UL listed, so they are up to code. And if you're putting one in, you will have to talk to your inspector and make sure that they understand what it is and have the instructions nearby. That's what's held us up on a couple of these simple switches before. What we found is city inspectors, until they've seen something, they don't know it exists. And even the real pros that deal with a lot of this stuff at like the help desk at the utility have not heard of a lot of this technology. So it's rarely used, so people don't bring it up a lot. The NeoCharge, one of my favorites, nice and easy, plugs directly into the outlet. You plug your primary output in this particular scenario. It's a dryer on one side. It's got a secondary output of the car charger. As long as the dryer is not running, the car charger will work. As soon as the dryer turns on and current is sensed there, then it'll just shut off the car charger. Or what we use these a lot for as a secondary output is a heat pump water heater. Here's another thing is we have these things called circuit pausers. And actually it's the simple switch can be used as a circuit pauser as well. And basically what it does is there's CT connected clamps that go on the main wiring. And they're going to sense when the load wiring is going to be 80% of whatever you set it up in here. So in this particular case, it's going into a 200 amp panel. So when this thing gets to 160 at 80% of capacity here, it'll just pause that other circuit until the power load comes down in the house. So on Thanksgiving, when everybody's running everything and all the burners are on the induction range and you got the turkey going and you know, all the good stuff's happening with the heat pump water heater because your in-laws are taking another shower, and you got the heat pump running because somebody left the door open, even though the stove's probably enough to keep the house warm in most of the houses we work on because we tighten them up pretty good. That's another thing. When you're using your oven in the winter time and you're done cooking, leave the oven door cocked open, get that free heat into the house. It's better that way. All right, solutions to a fuel panel. Add a heat pump water heater circuit and a couple more. So that would be a sub panel. I would pop a sub panel in that dryer spot. And you could do that with a quad as well and have a 50 amp sub panel. So maybe we land our water heater and our 20 amp heat pump here. So it just gives us some extra space. But once again, you have to run a neutral to these because somebody might come in and put some 110 volt loads in there. And if you don't put the neutral in there, it can cause some issues. Add a heat pump circuit and much more. These are really cool. I don't know who's seen these or not, but these are called smart panels. The Leviton one is a dumb panel with smart breakers. And then the span is a smart panel with dumb breakers. And I'm going through this whole thing at my house. I had a span installed at my house about 3 months ago, waiting for the latest software upgrade. It's supposed to be out by the end of the year that will actually allow the span to shed loads at whatever your peak load is. So if your house starts going over, it'll just shed whatever appliance you do. Right now, it has the capability to shed loads when the battery comes on, when the power drops out and the battery is providing power to it. I can program it to just take care of certain loads, so I don't need a critical loads panel anymore. The span is the critical load panel. This also does a really good job at monitoring the solar and the battery and kind of balancing out how much power we're using. And it's got circuit by circuit granular detail on how much energy everything is using, depending on how granular the wiring is in your house. If your house is built in 1978, like mine is, my washing machine in my garage is actually on the same circuit as my refrigerator in my kitchen. So we found that out by having a span. Safety. So last year we didn't install a lot of electrical panels. This year we got a few more going in, but it's almost the end of the year, so that story will tell itself in a month or so. We did 6 panel upgrades last year to get our systems electrified. I don't remember the ratio of unsafe panels versus needed to get bigger, but I think there was only one that I can remember off the top of my head, where we had an electrician come in and put an actual 200 amp panel in. The rest of them were all because they were like a stab lock Federal Pacific panel or a kind of a Zinsko with a burn. And if any of you guys haven't seen these Pushmatics, I haven't ran into one of these in a few years, but these are very interesting. You actually just push this button and it resets the breaker on the inside, and it pops that way. The downside to these panels is that the breakers are actually screwed to the bus bar. So if you're going to change a breaker out in one of these units, you have to kill main power for sure. Like changing a breaker out in a traditional electrical panel or adding a breaker, you don't necessarily have to kill power to the whole house to do that. But you certainly do with these. These are a big risk and kind of, not risk, but they're a little bit more, you have to respect these things a little bit more and be more careful with them and make sure you turn off the power before you mess with any of this stuff. So safety always takes top precedence over trying to conserve panel space. And it's important. I will never recommend to somebody that they should attach to another panel permanently that could possibly ever be unsafe. However, we did a job in Albany maybe 2 months ago, and they had a Federal Pacific panel. They were waiting to move into the house. Our job putting the heat pump in was going to be kind of the most disturbing part of the job. They really wanted to get that in before they moved in, and they had space in their FPE panel. So we went ahead and temporarily landed the heat pump into the FPE panel. But I mean, since then they had the electrical panel changed out a couple of weeks ago, so it's all back out, and it's all good. But we did it temporarily, so sometimes you might run into that, but get a little iffy, like adding a sub panel or something to one of these. Plan replacement. When you talk to your customers out there about their new heat pump application and you're laying out the loads and kind of everything that you're going to do, like we need to run a dryer circuit, we need to run a stove circuit, we need to put in the low energy heat pump system. Maybe they've got an air conditioner in there now and you're actually going to be reducing that load a bit, and then taking out the gas water heater, putting in an electric water heater, electric heat pump water heater. You may not want to do that in one of these. So, but what you do want to do is you want to help the customer understand the budget for taking care of that, along with all the other things they're going to do. Most of our customers don't electrify everything in their home at one time. Most of them are taking care of the low energy heat pump being installed, the heat pump water heater, insulation and air sealing. And if it's a big house with 2 stories, it's 2 heat pumps. So look for evidence of burning or damage in the panel. That's a red flag. That needs to be part of your safety check previous to diagnosing and giving them a subscription for the full electrification. Always check safety first. You'll see that in some of our other presentations. So what are some of the solutions? Watt diet is a great solution. Everybody's hearing a lot about this nowadays, the Watt diet. It was this fine gentleman, Tom Cabot, He's part of the Good Gridison group, and he's an electrical engineer, and he's really kind of, he coined the phrase watt diet. We use that phrase. We kind of coined the phrase good stewardship of the electrical panel. He used, so we're working closely in our communication styles on these things. So what is a watt diet? Slick and easy. It's choosing the right appliances to reduce your overall load so that we don't need to worry about other things so much, right? Like sizing in that panel. So right here we have two different types of dryers. If you guys haven't seen heat pump dryers before, heat pump dryers are low energy dryers. These are probably not something you would want to recommend to a family that has 5 children and they're constantly doing laundry. Heat pump dryers take longer to dry the clothes because they evaporate the moisture out of the clothes instead of like burn it out. But they use a significantly less amount of watts of power to do the same job. Ultimately, they do run longer, but still they use less power. So a peak load, there's not going to be as much problem with peak loading on these. And anytime we can fill out that form and put down what loads we're putting in and show 2,800 instead of 5,200, or excuse me, 2,200 instead of 5,200 for the dryer, that's a big deal. Dishwashers, you get that good Energy Star dishwasher versus the less expensive Hot Point one that's not really energy efficient. That can be 300 watts there. This is why it's the heart of the system, the heat pump. The heat pump is where we can make most of the change. If we are going to install in that 1,400 square foot house that I shared a minute ago, one of the other bids was a 3-ton heat pump system, kind of typical for that, you know, air handler, outdoor unit, not terrifically efficient, unitary piece of equipment, on, off, not modulating, versus, excuse me, versus putting in a low energy heat pump with just 2 breaker spaces. This is a massive amount. This is 6,000 watts difference in that end game. And once again, heat pumps, like car chargers, cannot be figured into the coincidence. So water heater is another one. We can do a heat pump water heater that's a 30 amp. You can do a heat pump water heater that's a 15 amp. We now install a lot of heat pump water heaters that are 115 volts. We don't even have to do this because they're shared circuits, and you can just plug them into an electrical, you know, like the string of outlets in your house. And you know, just to say a couple of words about those, is I was very skeptical of those because we'd installed lots and lots of heat pump water heaters over time. And then I went to a presentation on that. And the presentation was kind of focused on, hey, now you're the homeowner. You don't have to worry about doing a circuit. You can come buy one of these from the big box store and go put it in yourself. I still wouldn't recommend that to somebody. If you're like a licensed handyman or a plumber or electrician, hey, go for it. But if you're a guy that is capable of changing out a gas water heater, it's not the same. There's a lot of plumbing involved with it. There's a lot of getting it right. There's a lot of pieces and parts and attachments that you're not used to. I don't recommend DIY heat pump water heaters, but we do have 115 volt ones. I was skeptical. The Tech Clean California program gave me one for my house over a year ago now. Had it plugged in. It's a 65 gallon. I have myself, my wife, who would rather not have cold water on her. And then I have my 17-year-old son, who, anybody that has a teenager in the house knows there's a lot of hot water going there. But that thing it's been great. It hasn't missed a beat, but it's a larger tank than my old tank would have been. But so you have to do tank size on that so you can move the load around. But if we look at the sum of these different things, just by doing the watt diet, we're taking what could possibly be 20,400 watts here and making it 9,000 watts here. So 9,000 watts you can do off of a 50 amp breaker. This right here is like an 80 amp breaker, right? So big differences if you just make some wise decisions along the path. Okay, see where we're going now. So here's some examples from the field. So this is a customer over in Oakland. They have a main breaker at 100 amps. This gentleman is doing full electrification. I believe this house had 2 small heat pumps, one for downstairs and one for upstairs. It was an 18,000 BTU for the upstairs and a 12,000 BTU for the downstairs, both fully communicating inverters, both very small breakers. So that we added both those loads. We added a heat pump water heater, and we added he already had a 230 volt going to his stove. When we came out here, some of the stuff was mislabeled. I don't know if you can see it. One of these says sub panel anywhere. Didn't end up being an actual sub panel. Ended up just being feeding a junction box that was kind of hidden with a bunch of wires attached to it. It was like a rat's nest. So because they had multiple remodels done over time, the electrical system was a little crazy. So we found some extra loads that we didn't know existed when we got there. So the solution for taking care of him was a temporary simple switch arrangement. So we actually ran a sub panel. Inside the sub panel is our heat pump water heater and our 2 low energy heat pump systems. You can see the wire coming off of this. We took the wire that was normally going to the stove. We broke it inside the simple switch, wired back through with our wiring going outside. And so basically what happens is most people don't cook for several hours a day. However, you know, Thanksgiving is coming up on this one, and I'm wondering how it's going to turn out. But this is a temporary fix in his house until he can get approval to do the 200 amp panel. It was something to do with the weatherhead on his house and the design cost and all the stuff. So he's figuring all that out. But what happens on this one is the circuit going to the stove is now powering the simple switch. The simple switch is powers the stove as the primary circuit. And because it runs more seldom than everything else does. And then the sub panel is actually the secondary circuit. So it doesn't really matter what load I have on the secondary side. As long as the stove is the primary side, if I don't have any power going to the stove and I'm not using any power, I'm gonna provide power to here. But as soon as my stove comes on, it's gonna switch power from this to the stove, which means I'm thinking we didn't run the heat pump water heater out of this because that was an issue. But as soon as he turns on his stove, his heat pumps outside turn off. And so fortunately it's in the Bay Area where the heat is not crazy, but I'm more worried about Thanksgiving Day. If they cook all day in their range and have the range on all day, their heat pump won't be running. But this house was small enough that the heat coming out, the ancillary heat coming off of that, any guests they might have in the house, probably keep the house warm. But also if this customer operates these systems as we instructed them to, which is keep your house warm and keep your thermal battery loaded with energy. So keep your house warm. If the system shuts off because he turns the stove on, probably not going to be a big deal. I'm not going to run the stove long enough for it to matter if the house is already thermally equalized at the comfort temperature. So the scope was a 25 amp heat pump, 30 amp heat pump water heater, and the induction range. Simple switch behind the range with the heat pump, the sub panel. I think he wants to do his EV next, so he's looking for a larger outdoor panel, and then we're going to just take this out when that's time. Okay. Petaluma, a beautiful, gorgeous, amazing 1870 Victorian home. This customer wanted to get heat pumps installed for all the reasons that customers want to get heat pumps installed now, be cleaner for the environment, but also be more comfortable and more energy efficient. So they have a 125 amp panel, but this guy has a lot of stuff there. He's got like a garage out back with a significant breaker size, and there's a lot of stuff. The house has been remodeled multiple times, already has the electric range. So there's a lot of things going on here. So our strategy on this, and then we talked to him a little bit, found out that him and his wife literally live in 3 rooms in this 6-room house. And one of those rooms is a great big, like open space kitchen and family room and great room kind of area. So rather than put a ducted system in that would kind of have us keeping rooms that were not, not very efficient, warm all the time, we would have had a pretty much larger system in. We ended up going with a 3-zone multi-zone split head system, and I believe it was a 36,000 BTU. This is a big house, and he's doing an 18, a 12, and a 9 in the house, if I remember right, and works beautifully. Hasn't had to turn his furnace on. Cools the house, heats the house. We also did quite a bit of air sealing in this house, but really on an 1870 Victorian, all you can do is what you can do. Did that, insulated the attic spaces, really sealed up the underside of the house. But as we were working under there, we also found out that there's like other electrical, like sad room addition electrical junction boxes under there that he needs to get fixed. But so the challenge on this one was the 125 amp panel. We did not change the panel. We got everything on that panel with no problem. Part of the solution was putting in a plug-in water heater. You see they took this picture right before they kind of did all the bonus tightening. This is in a cabinet outside. It has a vent on the top. This is before they cut the vent in the side. And we also put foam board on the inside of this thing. And you can see they hadn't gotten to that phase of the operation yet. But 110 volt heat pump water heater in this particular application. Plug-in multi-zone inverted heat pump, 120 volt, and then the induction range. So he's able to do that, including his garage sub panel and all of the other stuff on 125 amps. If this would have went to a plug-in 230 unit, we couldn't have fit it into the capacity of the system. So that was the solution on this one. Keep the panel, wire it in, and get a plug-in water heater. So example number 3, this is one up in Davis. They have a 100 amp recessed panel. It's not my favorite thing to work on, but 100 amp recessed panel. As you can see, the gas meter here is conveniently right next to it. The starting point is the house was all gas, except they had an electric dryer and a small kiln in the house. They want to do full electrification and insulation. So we determined that the wire size on this house was adequate for 125. So we're able to like kind of bump this up a bit. The customer also wants a future EV, but the only way they were going to be able to get a future EV which is with some of the technology that comes kind of built into the span system. The span system has the span drive charger that works with this, that will actually throttle the charger based on how much energy you're using in the house. So it won't allow the unit to go over capacity because of that. Span also has the new application software that's coming out before the end of the year, which we can choose a maximum capacity, and it'll start shedding loads inside the house based on your priorities when you start getting close to load. These are things we have to do when wires come in from the street in the ground with no conduit. So big one here. It's a nice looking system. The Span is a really nice looking system. It's got a great app. You can see there was a fair amount of work. We got some great pictures of all the wire we had to pull between here and here. It was kind of a nightmare, but I wouldn't say a nightmare. A lot of work. Okay. This house has a 100 amp Zinsco panel in the wall here. These pictures from when the house was getting converted and the solar or the Tesla battery was being installed. This house already had solar. Tesla battery was being installed. They had to put in what they call a critical loads panel. So they took the 110 volt loads out of here. They did a bunch of fancy work in the garage. brought the power in through the back here, came up into the critical loads panel. So all the critical loads were being backed up by the battery. This is the battery switching device here, the transfer switch. Everything ran through the gutters and came in. There was also some infrastructure on the inside. This particular house, the wires came through the garage. It's on the garage wall, thank goodness. The wires came in through the garage, kind of through the firewall as one big bundle, came into the top of the wall and came down here. What they had to do was actually go in there, disconnect these, pull the wires up individually that were going to go into here, and then they put them into a gutter panel here on the inside of the garage. And then they took that gutter and then they spliced wiring going into here, and it was all labeled nicely inside the gutter. So this wasn't the last thing that was done on this house. There was also a span panel installed on this. So what we ended up doing on that is we ended up going in that same ceiling, taking everything loose out of the secondary load panel, pulling it all up, dropping it into a span panel on the inside. So this span panel is living right behind where this thing is, just on the inside wall. Gas meter's long gone. Span panel, low amp appliances, 20 amp, 30,000 BTU Mitsubishi heat pump system, plug-in heat pump water heater, standard electric dryer, induction range, and there's also a heat pump in this garage here, like a wall-mounted heat pump in the garage. No problem with loads. But span panel went in, took care of that. One of the cool things with these span panels, when you open them up, there's cool LED lights in here that show you what all the loads are, where all the breakers are and everything. So that's pretty cool. So this one was post in Vacaville, 125 amp with span. We also, because the gas meter was gone, because everything was electrified, we did this first, pulled that out. We were able to give an upgraded panel here, so we completely got rid of the Zinsco. The wire size coming up the street from the street was adequate for 125. So this is now fed with a 125 with a new square D panel here that feeds into the span panel. This is just full of blanks now. There's nothing in this panel really anymore. I don't think there's anything in that panel at all anymore. And so that's where that's at. Okay. So here's another one in Berkeley. This customer had a pretty big 125 amp panel, but they needed everything. They needed the gas furnace replaced, gas water heater replaced, the dryer replaced, or the dryer circuit ran, and the range. So what we ended up doing on this one was kind of a trip. It was going to be really hard to get the electrical. This one was logistically difficult because it finished a garage. This is on the outside, left side of the garage. You open the garage door in the front, garage is all finished. There were some wires going in for other things that I think we reutilized some existing circuitry in the house, but redesignated it here. But what we ended up doing, because the cost of like upgrading this panel or running all these circuits was going to be super crazy. It was like all this extra money. Customer was trying to justify how he was going to like come up with all this. And what we didn't want to do is we wanted to do the whole project if we could all at one time. So what we ended up doing though is we ended up coming off of here with the electrical for the stove, and then we put one wire over to a dryer outlet, and then we used a circuit splitting device at the dryer outlet. We plugged a pigtail into the secondary side of that, put the pigtail up into a junction box that onto a number 10 wire, took it over to the disconnect at the heat pump water heater, and then wired the heat pump disconnect into the water heater. So basically what we have is a shared circuit water heater dryer. So this is a family of two. They're going to use more hot water than they probably are drying clothes, but because the tank size was large enough for their needs, if they keep that tank charged up and they have an hour-long dryer cycle, they're not going to use enough water out of that heat pump for it to have urgent need to come back on. There's no reason why it just can't come on after the dryer is done with its cycle. The heat pump then cycles back up. However, some people do all their laundry in one day. You could do 6 loads of dryer laundry in one day, or you come back from vacation or something like that. It's important that customers understand what you're doing and know, like, if that's the case, they're doing all their water in hot, that's the case, they're going to have to let that heat pump water heater charge up again, possibly afterwards, if it hasn't ran in 6 hours. But the strategy we use for most of these heat pump water heaters is they're running from 9 o'clock at night till 5 o'clock in the afternoon, and then they shut off between 5 and 9 anyway. So there's plenty of hot water stored in this machine anyway. And people that are, cognizant of this sort of thing can make those adjustments internally. But this particular project's been in for a year and a half or 2 years. We haven't heard anything from the customer negative about how it works. Only a great review online about how great everything works, actually. But there was physical space problem. There was a problem with where we were going to put a new panel if we did. The capacity hit of running all the electrical to all the new electric circuits. And then we saved probably about $7,000 by doing it this way, because this would have been an expensive panel change. There would have been a lot of back and forth. So saved the customer thousands of dollars, and was able to give him full electrification. So panel left in place, circuit splitter between the dryer and the water heater, low amp heat pump. The heat pump we installed was low amp. We put this water heater right here. His laundry, the reason we decided to do it this way, his laundry is right behind this wall. So we actually, we came off of that plug. I think what we did is the plug, this LB goes into the junction box that the pigtail is wired into behind there. And that pigtail plugs into the other side of the circuit splitting device, and it's right behind there where the other stuff is. So that was a easy way to do it. Saved a lot of money. Circuit splitter, $400. All this wiring, thousands of dollars. Okay, so got the 20 amp heat pump in there, 240 volt heat pump water heater, attic air sealing insulation was the scope on this job. So let's see what else we got here. That's our last slide. All right, so join us in a month on December 10th as the Electrify Efficiently series continues. We'll be talking about some really cool stuff then too. If there are any questions, I think we have about 8 minutes left. If there are any questions, Alex?
Yeah, let's cover the last.
I can't hear you, sir.
We've got a few more minutes.
Okay, I see a question on here about 12/10 is a Sunday. What do we got going on here?
I believe that is for the Friday 12/8. So.
All right. Boy, hey, thanks for catching that, Paul. We will change. We'll see you all on a Sunday. It's good. Hey, thank you for joining us on Veterans Day. It's a holiday today. But I'm probably not going to be able to do one of these on a Sunday. Anyway, so the question I see here is, have you found that inspectors are familiar enough these days to understand and approve circuit splitters? We have to have conversations with them about circuit splitters. And once they know, they know. So like I have several Oakland and Berkeley guys that are very familiar now with simple switches. So, and then we just make sure that we always send a guy out whenever the house is being inspected. So the guy's got access on his mobile device to our Teams, where we have all of the on our SharePoint, where we have all of the documentation for this. So if the inspector asks something, my guy goes in there, pulls it up, shows him, look, you all listed, this is how this is work, it's fine. And so we haven't had really any issues with that. Kevin asked, I guess Alex sounds like you might have answered all these questions. That long rectangular box is called a gutter, and that's where we bring all the wires in because we're going to and fro with those. Thank you, Tommy. I appreciate that. We love delivering these things to you guys. We appreciate all that come in every time, and those of you that coming in just one at a time. It's really our pleasure to do this. We like getting this information out there. And if there's no further questions, I guess we can wrap this up.